2, we're going to cover how to find the area and perimeter of polygons that have diagonals as side lengths. And instead of using the distance formula to calculate the length of that diagonal, we're going to use the Pythagorean theorem. So remember that when you have a line that's horizontal or vertical, you can just count the number of units. But when it's diagonal, you actually have to do some calculations to figure out how long that is. So the distance formula is the one that's on the left. It's the one that we talked about before. The Pythagorean theorem, hopefully you remember, is this formula. And to make our lives a little easier, I've simplified it by taking the square root, because we are always going to be solving for our hypotenuse, which cancels that out. So this is the formula you're going to see pretty much on every page as to how to find the length of a line segment the quickest way. So let's try some examples. All right, so in example 2, we have a triangle that's already been color-coded for us so that we can easily see and figure out where all the numbers are coming from. And we want to find the perimeter. So let's always start by looking for the sides that we can just identify by counting. This is horizontal, so it's really easy to count that this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. So we already know for our formula, we're going to have perimeter equals 10 plus. We just have to figure out what this number is going to be, and we have to figure out what this number is going to be. And that's what we're going to do in 1 second. So just as a reminder, that the formula to find the length of our diagonals is going to be the square root of our a squared and our b squared. And these just represent the legs of our triangle. So let's see what that actually means. So we want to figure out how long this line segment is. Let's start with figuring out how long line segment AB is. And if you were to make a triangle on the outside, so kind of start by trying to create a little bit of a rectangle, right? How that's that part of the rectangle, and then this is the rest of the rectangle. These numbers on the side are going to be your legs. That's going to help us find this length. And these legs for the red triangle is going to help us find this length. So your A and your B come from counting how many units these are. So that's 3, 4, 5, 6. So this, we're just going to say is going to be our A. Our A is 6. And we'll do the same thing here. 1, 2, 3, 4, 5, 6, 7, 8. And then our B is going to be 8. You could change them. It doesn't matter as long as you have the numbers. So in order to find our the side length of AB, it's the square root of our A squared, which is 6 squared, and our B squared, which is 8 squared, not B squared. So I'm going to show you how to put all this math, all these numbers in a calculator online called Desmos, but let's just kind of set everything up so we can do all of our work together. So I'm going to do the same thing here. So we're going to find the length of line BC, and we'll do the same thing. So this is 2, so we'll say this is A. And again, it doesn't matter what order you put them in. So 2 squared, and this is 1, 2, 3, 4, 5, 6. This is 6. 2 squared plus 6 squared. All right, so let's use Desmos. So I'm going to open another tab. So we'll go to desmos.com. And we'll leave. Once you go to Desmos, you press Start Graphing. And when you start graphing, in order to type these values in, where you go is the bottom where there's a keypad, and you press the radical symbol. And what we're going to do is we're going to type 6 squared plus 8 squared. And this is your squared symbol. These are your numbers. And that tells us that the length of line AB is going to be 10. So I'll just kind of go ahead and write this here. So this is going to be 10. So I'll put 10 right here. And then we'll do the same thing again. And now we're going to find BC. So radical symbol. So we have 2 squared plus 6 squared. And this is going to give us approximately 6.32 units. So that would be the length of this one. So 6.32. And then when we add all of those numbers up, 10 plus 10 is 20. So this will give us 26.32 units. And that is the length of our triangle. All right, so the area of the triangle is going to be a little different this time. What we're going to do is we're going to treat it as if this is the shaded area. And in order to find the area of a shaded area, what you have to do is you have to find the area of the entire figure and subtract the inside. So we're going to go ahead and try that strategy on this. And if it doesn't make sense, make sure you ask questions and also just rewind the video. So let's find the area of the entire rectangle. So the rectangle has a base of 10 and then a height of 6. So a rectangle is base times height, which is going to be 10 times 6, which gives us an area of 60. All right, so now let's find the area of the blue triangle. Remember, area is base times height divided by 2. The base is 8, the height is 6, and divide that by 2. And that's going to give us 24 units. And we'll do the same thing for the red triangle. So the base is 2. So base times height divided by 2. Base is 2. The height is 6. Divide that by 2, which gives us an area of 6. So to find the actual area, we take the whole thing, which is our rectangle, and then we subtract each of our baby triangles out. So minus 24 minus 6, and that gives us 30 square units. And that's our area. Well, we're going to do the same thing. We're going to find the perimeter of this polygon and also area. So I'm not going to color code it while I'm writing it, but I'll color code it on the picture. So I'm just going to write AB, every single side. BC, because none of them are horizontal or vertical, so unfortunately we can't count. We're going to have to calculate the entire thing. And I'll write our magical formula at the bottom. So it's a squared plus b squared, and it is the square root of that. So let's start with AB, and I'll color code them like this, but not in the actual working out of everything at the end. So AB would be 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So this would be the square root of 5 squared plus 4 squared. All right, now let's go to this, which would be boom. So BC, so that'd be 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8. So BC would be the square root of 4 squared plus 8 squared. All right, now let's go to CD. This would be 1, 2, 3, 4, okay. And this would be 1, 2, 3, 4, 5. All right, cool. Notice how that's the exact same set of numbers that is up there. So 4 squared plus 5 squared. So these answers should actually be the same. And then we'll do the same thing on the left for line segment 80. So I'm going to guess this is going to be 8, 2, 3, 4, 5, 6, 7, 8. Yep, that's 8, and this should be 4. 1, 2, 3, 4. Right, so it looks like we have a parallelogram here. So that's the square root of 8 squared plus 4 squared. Okay, so since these line segments are the same, and so are A, B, and CD, I'm just going to calculate them twice and just repeat the numbers. So the square root of 5 squared plus 4 squared gives us 6.40, and that'd be the answer for both red and orange. And then the square root of 4 squared plus 8 squared gives us 8.94. So 6.40 and 8.94. All right, so 6.40, 8.94. All right, so for our perimeter, we're just going to add all of those numbers up. So I'll show the work here so you know where everything comes from. 8.94 plus 6.40 plus 8.94. And I'm going to do all of that work in decimals because there's a lot of decimals. So 6.40 plus 6.40, 0.94 plus 8.94. And that should give us 30.68. All right, so that's our perimeter. All right, so I'm going to do the same thing with the area that we did before. How we're going to find the area of our big old rectangle and then subtract the areas of our tiny triangles from there. So it looks like this is 4 plus 4, which is going to be 8. And this is 8 plus 5, which is going to be 13. Okay, so to get the area, it would be 8 times 13, which is going to be 104. So now let's find the area of each of our triangles. So this one would be 5 times 4 divided by 2, which is 10. Our blue triangle is going to be 4 times 8 divided by 2, which is 16. Our orange triangle is going to be the exact same thing as our red one because the numbers are the same. And our green triangle is going to be the exact same as our blue one because the numbers are also the same. All right, so to get the area of our entire triangle, we're going to subtract our our entire polygon. We're going to subtract our triangles from the rectangle. So we're going to do 104 minus 10 again, minus 16, minus 16. And once we do all of that work, that should give us what we need. So 104 minus 10, minus 10, minus 16, minus 16, which is going to give us 52 square units. And that's that.